In this example, we want to find a composite function that will express the given function that shows the y in terms of x. So in other words, each function that is shown in terms of x, we have to show as a composition of any one or any two of these individual functions. All right, so we have the f function, the g function, the h function, and the j function. So for each of these 6 cases, we must choose at least 2 functions that can be plugged into the other that will give us the composition of functions. So the first example, notice that x is raised to the 3rd power, and then, so to speak, after that, it is square rooted, right? Because that bottom 2 in the power tells you that it's going to be a square root. All right, so the first thing I would do, I would look at the x to the 3rd power, and I see that h of x is raised to the 3rd. H of x shows you the x to the 3rd power. All right, so we can say x to the 3rd power. All right, that's the h of x. And now what you want to do, you want to take the square root of this x to the 3rd. So if you take the square root, notice what will happen. As a result of this, you're going to have basically the h of x being plugged in to the g of x function, right? Because you're going to take this x to the 3rd and you plug it into this x instead of x. You substitute with this x, you get x to the 3rd square rooted, right? So basically, you're putting in the x to the 3rd inside the input of the g. Thus, we can place the g as the outer function, and we know that the result is going to be this composite function, right? Now, in the second example, we have x raised to the 1/4 power. All right, x raised to the 1/4 power. So notice right away that if you take x to the 1/2, which is basically equal to the square root of x, you will get that. However, if you take x to the 1/2 and you raise that to the power 1/2, you will get x to the 1/4 power. So what happened? So x to the 1/2 is the square root of x. Now where's the square root of x? It's the g of x function. So basically what you did, you put the g into itself, right? So you're taking the g of x, and then you're taking this g of x as an input of its own function g. So the result of which is going to be x to the 1/2, which is the square root of x, square rooted again, right? Which would give you basically the 4th power, the 4th root of x, all right? So that would be the g of x. So that would be the respective composite function for question 2. Now the next example, we have 4 times x, okay? 4 times x. Now notice that definitely it has something to do with this last function, j of x, because it's already giving you 2 times x. So notice that if you multiply 2 by 2 times x, you will get 4x. So what does that mean? It means you're taking the j of x, okay? You're taking the j of x, and then you're simply going to put 2x instead of this x here, right? So you're putting the j of x in itself. So just like in the GG case, the JJ case does the same thing. If you put in 2x inside the function, and I'm going to show you on top here what happens. So notice that the j of 2x, right, j of jx, is equal to j of 2x. That's equal to 2 being multiplied by the new input, which is the 2x. Right, so the 2x replaces the x. Right, so that means 2 must be multiplied not just to the x, but the 2x as well, right? So 2 times 2x is giving you exactly 4x. That's why j of jx putting the function as an input to itself works, just like it worked for the GG. Okay, so that's for question 3. Now for question number 4, this is a little bit trickier, but if you do it step by step, you will understand what's going on. Notice right away that x minus 3 is the key. You already have x minus 3 as the f of x. So you're going to take x minus 3. Okay, that's x minus 3. Notice that then if you cube that, notice that x minus 3 is cubed. So x minus 3 cubed means what? It means you're taking the f of x function and you're inputting it into the h function, right? So basically you're making the h as a function of f of x, right? So that's x minus 3 cubed. Now that's not everything. Notice that we're going to have more than two functions participant in the composite function. We're going to have actually 3 because now we need to take the square root. So notice that if you square root x minus 3 cubed, what you're going to get is you're going to take this whole composite function that you created and you're going to put it under the square root of the g, right? Because the square root is going to be happening when you input the entire composite function h as a function of f as a function of x into the input of the g, right? Because you're square rooting that. You're square rooting the x minus 3 cubed. So naturally what you want to do, you're going to take the g as a function of h as a function of f. All right, so this is a very large composite function so far that we've seen. But if you take it step by step, you see it's not that hard. Now the next example is x minus 6. Okay, now this might be a little tricky. You might experiment with several options. You could do, you could try to do, let's say, twice the function of x. All right, twice the function of x. But the problem is if you do twice the function of x, you will get 2x minus x. But here you need x minus 6. Okay, you need x minus 6. So what do? You definitely need to try to think of j and f. All right, you definitely need to think of j and f. So if you plug in f inside the j, it might work. So let's try that. If I plug in f inside the j, what would I get? So j as a function of f as a function of x would mean what? It would mean that x minus 3 takes the new input of the j. Right? So that would be what? That would be j as a function of x minus 3. So what happens? Let's see. That means the 2 will be multiplied by x minus 3. All right? But now the problem is, again, it's going to be 2x minus 6. Right? But we need only x minus 6, so it's not going to work. Okay? So you can't put in the j inside the f, and you can't put the f inside the j. Now what you can do, remember that sometimes a function goes inside itself. So what I would experiment, I see that I can plug in the f inside the f function itself. So if I do the ff, notice what we're going to get. We're going to get f of x minus 3, right? Because if you plug x minus 3 inside itself as a new input, you would have to replace the x with the x minus 3. So as a result of which will be x minus 3 minus 3. And this is giving you exactly x minus 6. Right? So once again, this is equal to the f of x. So ff, right? That will be the composition function. Now in the last part, it's going to be fairly easy. Once again, when it comes to square rooted expressions and the powers, I would look at the first term. All right, the first term gives you the x cubed, and x cubed is the h. So I know if I put in the h of x minus 3 basically is going to be x to the third minus 3. so basically we're gonna plug in the h into the f. So f of h of x, right? So the f of h of x. Notice that will give us exactly what we want, because if we plug in the h of x, if we plug in the h of x here, in the input for the f, we will get x to the third minus 3, right? So we're going to get that. But one more step is to, once again, like in one of the previous problems we've done in question number 4, we square rooted last, right? So we know we have to plug in this whole fella into the g function, right? So we're going to use the f of h of x as the input of the g in order to square root that result, right? So we need, if you want to square root this, you're going to have to square root the f of h of x. And of course, that means you're going to put it as the input of the g. F of h of x. So that would be your respective answer for question number 6. Thank you so much for watching. I hope this was fun and helpful. See you in the next video.